Why is cooling more complicated than heating? Mike works in a laboratory for a chemical company. So far, he has only used heating circulators. Currently, he is looking for a device in order to cool down a chemical process. Mike notices that cooling circulators are significantly larger and cost more money than comparable heating circulators. He wonders why that is. Doesn't cooling work in a similar way like heating? We want to answer that now. As with Mike's heating circulator, the technology for heating consists of an electrical resistance. This gives off heat to a medium. Electricity is all that is needed. Adding heat is therefore relatively easy. Cooling, meaning extracting heat, on the other hand, is a cycle with several components and physical processes happening. In order to cool an object or a medium, something even colder has to be produced. The temperature difference should be as large as possible so that a lot of heat could be extracted. For this purpose, special fluids, so-called refrigerants, are usually used. They have the property of being able to absorb a lot of heat when the state of aggregation changes. A cooling device with a refrigeration circuit always uses such a refrigerant. At low temperatures and pressures, it absorbs heat. At higher temperatures and higher pressures, it gives off heat. Let's take a closer look at the refrigeration cycle. The gaseous refrigerant is compressed in the compressor, which increases pressure and temperature. The hot refrigerant then enters the condenser under high pressure. There, it gives off heat to the environment or the cooling water. It changes from the gaseous to the liquid state. It condenses. A throttle valve then reduces the pressure of the liquid refrigerant. Afterwards, the refrigerant enters the evaporator under low pressure. The state of aggregation is changed again there. The liquid evaporates. The required heat for this process comes from the medium. It is precisely at this point of time when heat is extracted from the medium, meaning it is cooled down. This cycle is repeated until the desired target temperature is reached. The selection and size of the components used determine the cooling capacity of the device. Cooling capacity describes the amount of heat that can be extracted per unit of time. The cooling in Mike's household refrigerator works on exactly the same principle. The extraction of heat is therefore a complicated, multi-stage process. For this reason, cooling devices are usually larger, louder, and more expensive than pure heating circulators. However, they have one decisive advantage. They can cool.